Hi, it's Carly McAvoy. I'm still looking at applications of the normal distribution. In this particular example, the figure below represents the ages of men who seek hair replacement therapy. The mean is 50 and the standard deviation is 10. What is the probability that a man seeking hair replacement therapy is between the ages of 40 and 50? So when we ask the probability, we're asking about the area under the curve. So we want to know the area here between 40 and 60. We don't have to change that into standardized form. We can use exactly what we have there. So I'm going to do second function data. Actually, I'm going to do on and clear all because I have some weird data in there. Second function data over to distribution and down to normal CDF. Now I want to put in my mean because it's going to give me the standard of 0. My mean is 50 and my standard deviation is 10. And now I can hit down and I want to know from what range. I'm looking at 40 up to 60. And that gives me the area of 0.6827 if I round to the 4 digits. So the area under the curve, so 68% of the men seeking that therapy would be between the ages of 40 and 60. Okay. Find the area of the shaded region in this one. The graph below depicts IQ scores of adults, which are normally distributed with a mean of 102 and a standard deviation of 15. So what I know is that right here in the middle, that would be somebody with an IQ of 102. So I know that this is a negative z-score. It's not standardized, so that's 80. But anyway, if we want to look at the area to the left of that, and that's what the calculator does best, is looking at things to the left, so that's fine. Second function data, I can go over to distribution. Notice I didn't clear out my values. So look what happens when I go to normal CDF now. It tells me I have a mean of 50 and a sigma of 10. So you have to be really careful that you don't leave those in. My mean is actually 102. I could clear it or I could just type over it, and my standard deviation is 15. Now I want to know the lower and upper value. I want to look everything to the left, so negative 1e99, and up here on the right I go to 80. And it gives me an area of 0.0712. So 7% of the population would have an IQ of 80 or less, if this was true. I don't know what these numbers really are. Okay, assume the cost of scientific calculators are normally distributed with a mean of 105 and a standard deviation of 12. Find the probability that a randomly selected calculator has a cost between $90 and $110, and find the probability that a randomly selected calculator costs more than $120. So I want to draw the picture here first for the first one. The mean that we were given is $105. That's the mean cost of that, and a standard deviation of 12. And it says, find the first one, find the probability that a random selected calculator has a cost between $90 and $110. So we're interested in something down here, 90, and over here, 110. My drawing isn't all that fantastic, but what I'm looking at then is the area between those two values. So I'm going to use my calculator, second function data, 1 to the right, down to normal CDF to find the area. My mean was 105 in this problem, and my standard deviation was 12. And then my lower bound, is 90, and my upper bound is 110. And that's going to give me an area of 0.5559. Rounded to 4 places. Now let's look at the other one, the probability that a randomly selected calculator costs more than $120. So we have this really terrible picture, and we're at 105 for the mean, and over here is $120, let's say, and we're interested in the area over here to the right. So we want to be careful because when it finds the area for us, it's going to find the area to the left. So when I get that area, I'm going to subtract it. They're going to find this area. That's what the calculator is going to find. And I want to know the one to the right. So I'm going to think about that a little differently. Well, no, this one I can do exactly like that. Sorry, I'm thinking about a z-score. We're fine on this. So the distribution, because when I find that, it's going to let me say, I still have 105 and 12, but it's going to let me say, are you looking to the left or right? Sorry, this calculator is lovely that way, which most of the calculators you can do that. If you're using the tables, you're talking about area to the left, but we're talking about 120 and up to infinity, so that's super simple. And that's going to give us an area of 0.1056, or in other words, about 11% of the calculators are going to cost more than $120. All right, have a fantastic day, and I'll talk to you next time.